Aduh.
I think I've got an idea.
I've got an idea. I've got an idea. Hi guys, I'm Kean.
And I'm Zhenyang.
And we're from SMK BBP1.
Today, we're going to show you 4 scientific phenomena that are interesting in our daily lives.
Let's go.
Go!
The first experiment which we'll be doing is a floating droplet experiment.
Or you can call it the Leiden-Frost effect.
The apparatus which we'll be needing is an infrared thermometer, a metal spoon, a heating stove, a bowl of water, and a dropper. In this case, is a straw.
So, let's get down to the procedures. Firstly, we'll heat up the metal spoon up to the Leiden-Frost point, which is 200 degrees Celsius. And the temperature will be measured using an infrared thermometer. So, after that, we'll drop a few drops of water onto the metal spoon and observe.
So, how does this work?
Before that, we are going to explain how water evaporates in chemistry terms. When water is heated, the energy of the particle increases until a point where liquid turns into gas.
So, just how and when does this Leiden-Frost effect occur?
In order to better understand this effect, we are going to explain in the form of animation.
During normal boiling, let's say at 100 degrees Celsius, heat is transferred throughout the droplet. Therefore, more time is required to heat up the water molecules. However, during the Leiden-Frost point, which is at 200 degrees Celsius and above, water touches the metal surface, evaporates instantly, causing a cushion of water vapor to form under the water droplet, causing the water droplet to hover, and also slows down evaporation.
That is the end for the Leiden-Frost effect experiment. Let's move on to the next bit.
So, for the next experiment, it's called the suck experiment.
It's not you that sucks, but it's the Venturi effect. Wow! For the apparatus, we'll be needing a vacuum cleaner that can blow, some PVC pipes, some masking tape, 2 straws, and some debris. Are you done yet? The nozzle is fitted to the straw at an angle.
Why exactly does this happen?
Well, first off, the nozzle is ejecting air into the straw at a very high speed. When the air is ejected out of the straw, this high speed produces a low pressure at the middle of the straw. Therefore, the atmosphere with a higher air pressure rushes in, along with the debris.
With that out of the way, let's get to the next experiment.
The next experiment is dubbed the self-balancing wheel. The apparatus needed are simple: a bicycle wheel
And a rope.
Firstly, we hold the bicycle wheel upright and spin it. As you can see, the bicycle wheel stays upright and spins along its axis. So, why does this happen?
This effect is called the gyroscopic precession effect. When the wheel isn't spinning, it falls to the ground due to the gravity pull. However, when the wheel is spinning, the gravity force exerted on the top of the wheel is transferred 90 degrees along the wheel's rotating motion.
This causes the wheel to spin along its axis.
Gyroscopic precession is also used in toys and even vehicles.
For example, fidget spinners.
As the fidget spinner is tilted forward slightly, it slants to the right as the fidget spinner is spinning in an anti-clockwise direction, and vice versa when the fidget spinner rises up.
Now let's move on to the last experiment. Now moving on to the last phenomenon, we'll be doing the hot or not experiment.
And we'll be showing you the misconceptions about temperature. So, for this two-part experiment, we'll have a plastic plate, a metal plate coated with black paint, an infrared thermometer, a glass casserole, and a lot of ice. So, let's get started.
Firstly, place the metal plate and the plastic plate into the casserole.
We waited for an hour to allow the ice and the plate to achieve equilibrium temperature. Then we touched both of the plates to feel which is colder.
Next, we place the plates into the refrigerator and place an ice cube each of the same size and shape onto each plate.
Let's see which melts faster.
So that's why exactly does the ice melt faster on a seemingly colder metal surface?
Well, according to the infrared thermometer, they are at the exact same temperature. But metal transfers hotness and coldness much more efficiently than plastic does. So this causes the ice to melt faster on the metal plate. This also tells us something interesting about our body, that we are not sensing temperature, but we are sensing the rate of heat loss through our skin. So, through these 4 experiments, we hope we are able to change your perspective about science in our daily lives. And lastly,
thanks for watching.